Well, this is what it looks like today. Here are two layers which can be explained by science as constituting the forest floor. So when everything gets covered, at the bottom you have the forest floor. But this is very interesting because there are two forest floors just a hand's breadth apart. Are these two forests that were just a hand's breadth apart? That doesn't make much sense. Secondly, when you take this to the lab and you grind it down and you have a look, then you'll see that the material in it is water sorted. So did these forests form underwater? Because if you pick up a forest floor today, everything is jumbled up. A twig, a leaf, a twig, a leaf, a twig, a leaf, needles, pines, everything mixed up. But not here. Here it's water sorted. That's another interesting scenario. Here's a tree dug out. Notice that the roots are definitely ripped off. Now, if a forest grew and it got covered and the trees got buried upright, would the roots be ripped off, yes or no? No, doesn't make any sense. Notice the layering that we see over here. And here's another interesting thing. This is a turbidite flame. That's a mud flame. So this must have happened underwater. Now, a solution to this problem came when Mount St. Helens erupted. Here we still have a lot of volcanic material and geysers. And this was St. Helens before the eruption. Notice this beautiful glacier on the top. And when this first eruption came, then the water melted and rushed down the south side. There were two cycles of eruption. These were the lakes that surrounded the mountains. This is Spirit Lake with a glacier on top and the beautiful forests around. And then in 1980, the mountain erupted, not with an explosion. It just erupted and the ice melted on the top and formed this flood down the south side. Notice how the trees started to be ripped out. And notice that these trees don't have any branches on them as they float in the water. Then it was a great catastrophe. Everything was covered in mud. Houses were buried, all kinds of things. A month later, there was the huge eruption, which I'll talk about in a moment. But on the south side, this is what we see. Trees ripped out, and here they are. What do you notice? They are orientated in the direction of stream flow, and they have no branches, and their roots are ripped off. Here are some giant ones that were ripped out like that. And here you can see dents in the trees, because as the trees roll in the water, the branches are ripped off, and as they bash up against each other, the bark is stripped, and so these trees are without bark, they don't have any roots, and they don't have any branches. And if you look at the layering, it looks exactly like in the petrified forests. Then a month later, there was this earthquake, and the greatest landslide witnessed by modern man took place, and the top third of the mountain slid away and released huge pressure, and the mountain erupted. But notice that the eruption takes place to the north side. The south side is unaffected. So we have two sides of a story here. This is amazing stuff. And it explodes with a force of 500 Hiroshima atomic bombs. Boom. And puts enough debris up there to account for 1 ton of material for every person living on the planet. Cars are slung kilometers across the terrain. Huge trucks were transported kilometers across, and the forests were stripped bare and buried. This is what it looked like before the eruption, and that's what it looked like after the eruption. So this huge mass of material came and crashed into the lakes. Now you can imagine what that did to the water. What would that do if a huge amount of material just fell into a lake? Well, it would displace the lake. So there was huge tidal waves, just went, and they just rushed through the area, and they cut canyons, and they gathered the debris of wood and washed it back into the newly forming lakes as they formed. Here's a steam crater that formed. There's a human being standing over there as a scale. So hot material lands in the water, explodes, and forms that crater. Here's a canyon. This canyon formed in seconds when this water rushed through, and this material here was formed during this eruption. So all of this happened within a few minutes. And if they look at the layering, they would imagine that this must have taken millions of years of time, but it happened in a very short time period. Huge trees transported, ripped out, some of them sheared off by the blast as if cut by a blade, and transported many miles in these mud flows in the upright direction. Here's another one, transported upright in a flow direction. Huge quantities gathered in the lakes. This is Spirit Lake. Here are these things gathering, and then very soon, some of these trees started floating upright. Now, here's an interesting story. So they wanted to have a look. So down went the divers, and what did they find at the bottom? Huge quantities of bark. Thick layers of bark. Did you know that some coal seams consist of nothing but bark? Inexplicable in a forest situation. Impossible to explain. Here it is. The bark settles down underneath, the logs float on the top. The brown coal that I showed you of the largest mine in the world consists of the logs, and some of the lower layers consist of nothing but bark. So here these trees float upright. Now what if there was another eruptive cycle and they were buried while they were floating upright and mud buried them from the side? How would they be buried? Upright. So they took a scanner and they measured how many trees there were in this lake, Spirit Lake, floating upright. And they found 19,000 trees. So if we go back to our petrified forests, you see all these layers of forests with upright and horizontal trees in them. And these could have formed rapidly. Now, one interesting thing that they did is they took samples from all across the column and sent it to the lab for analysis. And guess what they found? Each eruptive cycle today has a special chemical fingerprint. You see, as the magma forms under the volcano, it's new material. When it blasts to the top, the chamber at the bottom is empty and has to fill up again, and the mountain is quiet until it has built up enough pressure for the next cycle. Now, today they know that if those cycles are more than 3 months apart, then the chemistry is different. Well, here, the chemistry at the bottom and at the top is exactly the same. So this tells us that the whole process couldn't have taken longer than 3 months. That fits beautifully into the story. We can also see why the trees are orientated, because obviously it happened in water, and even the upright trees are buried in a particular way. Not all trees are perfectly round, so let's say it has a big rootstock on the one side, it'll be orientated in the direction of stream flow. Now, if this was a local phenomenon just here in the United States, that would be one thing, but it's universal. This is Africa, the petrified forests, exactly the same scenario. They are stream orientated. They don't have any branches, they don't have any bark, they're all lying in the direction of stream flow, their branches are ripped off. The exact same scenario is in Europe, in Australia, here on your continent, everywhere in the world, you find this.